Hello.
Hi.
Hi, Adam.
Hi,
Hey, good
Adam.
to
Yeah,
see you.
nice
How?
to nice to meet you.
Yeah. How's everything going? How are you?
Yeah, good, good, pretty good. This is our last day of the school term, so it's going to be nice to have a little bit of a break from school.
Yeah.
So
Nice.
yeah.
Hi, Jeff.
Hello, how are
Good
you?
to see you again.
Yeah, nice to see you.
Yeah. So today I had the office meeting because I think Adam had some questions about some of the I think Unit 3 and Unit 4. Is that right, Adam?
Yeah, yeah.
So but Jeff, are there some things I feel like you might be a little bit more you progress a little bit, but maybe if you have some questions I can sort of quickly get out of the way, because I think Adam's going to be, as far as I know, we're going to be going to the very basics of like what an expected value is, standard deviation, very sort of foundational concepts. I was wondering if maybe you had some questions that I could help address and get out of the way, and then you can sort of decide if you want to stick around.
Yeah, sure. Well, yeah, I'm okay with that kind of quant stuff. Like you might have seen, I finished the assessments.
Yes. Yes.
Yeah. But yeah, I was mainly wondering more about the assignment, or like, when will we sort of be getting more information on it, or are we expected to have started it already?
Which assignments?
Oh, the group assignment.
For this week?
Or just in general, like.
Are you talking like for the final team assignment?
Yeah, the 30-minute presentation.
Oh yeah. Okay, so that we were gonna introduce more in the middle part of the term, but you're welcome to start thinking.
Okay.
So yeah, but you are welcome to start thinking about it, and especially if you have work commitments. So maybe we can gather with your team, just as a team, your own team, and we'll sit down for 30 minutes, think about the data sets that you guys might have of interest. Can you remind me sort of your background and sort of what data sets you feel like you might be able to share or not, or like sort of what you'd be interested in sort of looking at?
Well, our whole team's a finance background.
Okay.
I guess the data set that I would be most familiar with is the sales and like all the accounting side sort of figures. But yeah, last term I did economics, and we worked with a data set from the Australian Energy Regulator for like electricity. Yeah, but we didn't do a bit like deep. We didn't do a deep analysis. It was more just looking at supply and demand.
Right. Yeah. So I think this would be why don't we do this over the next week? We'll schedule sort of a team meeting for your group, because I feel like you guys might be a little bit more you guys have a bit more quantitative background than some of the rest of the class, and so you guys can start getting ahead of that. And so I think the main thing that you guys will have to think about between the finance group is sort of what data sets you feel like could be within scope, but also of interest to you guys. Like in the past, we've had people from PwC or KPMG. They've brought in their data sets for them to analyze, and it's been a great project and help them in their own work. So I don't know if you're able to, so you'll have to like, get permission from your company or whatever, or you can just choose something of interest. So people have done just like, housing price increases and sort of predicting which areas in Australia might be more sensitive to inflation or interest rates or whatever, so there are a number of interesting data sets that I can suggest you. Have you looked at Kaggle before?
No. What is that? Kaggle.
So it's a great site for data scientists, and they've got a number of great open source data sets, and from finance to health, so to investments. So that's something. If you feel like if none of you guys want to share your own private data from work, that's another good source of data.
Okay, Yeah, thanks.
Yeah, so then and then so the way that final assessments will work is you guys will spend basically 1 to 2 weeks, scoping out the problem, sort of figuring out what the data set is, what the hypothesis you guys are trying to answer. And then you'll spend basically another week. Each of you guys will sort of divvy up like what piece of the problem you guys want to solve and analyze, and then communicate through Tableau. And then at the end of the last week, you'll just basically work together as a team to then present it as if you're presenting to either a board or to C-level execs, where you guys all have about maybe 2 minutes to present your piece of the puzzle or your hypothesis that you're addressing. So I think it should be for you guys, if you guys are in finance, I think you guys will have a easier time of it because you guys probably have some quantitative background. And I believe one of your classmates actually might have worked at Tableau.
Not my group.
No, not your group. Okay. So anyway,
Yeah.
so I don't know if you've had any experience with Tableau, but if you already had experience with Tableau, it should be very straightforward. If you haven't, then you might struggle a little bit to go through some activity and exercises, which we'll walk you through to get to that point. But yeah, so that's basically that's the final assessment. So you're going to be assessed based on sort of the data analysis portion, which is related a little bit to the data set that you're looking at, and we'll have, we'll scope that out together. And then you'll also be practicing your data storytelling skills. So out of that data set, there's probably going to be a lot of things and a lot of variables you can be looking at. And then, we'll go through in chapters 7 and 8, sort of, figure out like how to highlight which parts of the data you'd want to communicate. And then so basically at the end of the day, you want to come to some type of actionable decision from your data insight. And I think that's, there's not really too much to it. I think you'll probably, most student groups will probably spend a lot of the time really upfront scoping the data set and analyzing it. But once you figure out the question that you want to ask and how to solve it, everything else falls from that.
Yeah, sounds good.
Cool. So yeah. Did you have? Yeah.
I just wanted to go over just very generally what the open book test is. The next assessment, is that just like units 1 to 4 or something?
It'll be units 1 to 5.
1 to 5. Okay.
Yes. So it'll cover everything up to units 1 to 5. I'm pretty sure we're gonna, unit 6 is going to be off. Will not be on there. But just go through unit 6 just very briefly, because there are some things that we allude to earlier, but we won't go heavily into it. And it's, I think as long as you've gone through the activities and the exercises, I think you should be fine.
Yeah, sounds good.
Yeah.
Yeah, thanks.
Cool. So yeah, you're welcome to stay here. So Adam, I think Adam and I, we're going to go through sort of, the very sort of basics and sort of the notation of probability and sort of figuring out how do you work these equations, how do you apply it, and then also, I guess, with an eye for the assessment. Is that right, Adam?
Yep. Sounds good.
So why don't Jeffrey, if there's no other questions, I'm going to turn my attention now to Adam.
Yeah, that's
so
fine.
Adam, why don't you kick it off, Adam?
So yeah, just basically what we said in the chat, just how to work out the equations for what's most likely going to be in the test. So what were they? Just like unit 4.
Okay. And did you go through unit 3? Did you have any issues with unit 3, or unit 3 was relatively straightforward for you?
Unit 3 is pretty straightforward in terms of the probability.
Okay.
Yeah.
Cool. So I think in our chat, you had mentioned the expected value, that you were unfamiliar with that notation and sort of how to think about it. Is that correct?
Yeah. Well, just obviously, I don't have a quantitative background. I know that you said that the equations look scarier than how they are. So just kind of how can we reduce that?
Okay.
And society, just showing me like what, like
Yeah.
how basic it is. Yeah.
Yeah, sure, absolutely. So I'm going to do a quick screen share, just making sure we're
Thank
aligned
you.
on the same thing. So my understanding is that you were looking at equation 4.1. Can you see my screen?
Yep. Yep.
Is this the equation that you're looking at, that expected value?
Yeah.
Yes.
Yeah. Well, just just like what Jeffrey said, just kind of just what's in the test. So you said from units 1 to 5. So basically a equation like this. Yeah.
This will definitely be on there.
Okay.
And this will be very important when we talk about, asset allocation, and we start building up to covariance and, things of that nature. Like this is sort of one of the really basic definitions. So, so the expected value is really, are you familiar with the term like mean and average?
Yeah.
It's in some ways, it's basically that, but I think maybe it's this sigma notation, is that sort of what, and sort of this P of X of I and X of I, is that sort of what's tripping you up a little bit? Yeah. So the way I would think about this, and so here's right above here is sort of so I think I'm gonna go through the procedural piece of it with you first, and then from that procedure, you'll sort of understand how the calculation works, and then I can sort of describe to you from a very theoretical point of view what the expected value is. But so basically, so that you can, the reason why I'm going to do it this way, so that you can actually understand in the ebook how to go through that application of the formula based on the table. So here we have the probability distribution of home mortgages approved per week. So let's say for 0, the probability was 10%. For 1 mortgage is approved per week, it's 10%. For 2, it's 20%. For 3, it's a little bit higher at 30%, and it sort of goes back down. And if you were to graph this out, it would look sort of like what we call a normal distribution here. So this is just a visual representation of this table. Does that make sense? Okay. So now so the question is, how do you use this equation? So what we've done here is we've just broken down exactly what we just discussed there. So what this notation is just your summating the, excuse me, I've got a little cough.
That's all right.
You're summing the probability of the ith outcome of X, which is your discrete variable interest, times the probability of that occurrence. So we've already labeled that here, which is the probability. And then so the probability of the 0th event is 10%. So 0 times 0.1. So 0 times 0.1 is 0. And then the probability of 1 mortgage being approved is 10%. So that's 0.1. And then you just sort of, it's a little bit mechanical and, mindless, but this is basically just, if you want, I can go through the entire thing, but you're just summing.
No.
Yeah. So basically, that is probably the scariest part of this notation, which is really just us. And the reason why we use this notation is it's just, for those that are practicing it, it's a simplified way to represent this whole calculation here. But if you see this on the test, that is all that means. So then,
So do you suggest the best way to work it out in the assessment? Do I do it on paper, or do you think?
Yeah, so I think because you're coming in without a statistical background, I would recommend, just for your first pass understanding, to go through these exercises and activities, because and actually what we're doing right now is just like going line by line, just understanding what this, if you were given this on an assessment, this is what you do. But actually, as I mentioned in our correspondence, we do have tools like Excel, and you can actually do, you can, if we do give you a table of numbers, you can just calculate the expected value from there. So then that saves you time on the assessment.
All right.
But so that you understand what the notation means, so that it's just not just all Greek to you, like literal Greek to you, I would physically just work out just what it is in case it's not clear how to
Mhm.
compute the expected value. Like
Yeah.
if it wasn't clear to you, like why we chose 0 times 0.1 plus 1 times 0.1, like I would just do it once or twice just so that you
Yeah.
are familiar. And then,
Yeah.
so I hope, so now to go to the more theoretical understanding of the expected value. So you can think of anytime you run these statistical experiments, there's going to be some central measure of tendency, which is sort of like the center of mass of that distribution. So here, the center of mass is going to be around. So I think you have a background in tennis, right, Adam?
Yeah.
Yeah. So when you think about like the center of mass of something, where you want to hit your rackets, like right in that sweet spot, like this here, that sweet spot is 3. So, but in other cases, the mass of the center of mass could be like 4 or 5 or 6, and it's like it shifts the whole distribution to the right. And so your expected value is just sort of just a way to express that measure of central tendency, that's sort of language that we use to describe that distribution, where the majority of it. And so when we talk about normal distributions, which is it's particularly important when we're talking about these type of expected values, you have a very nice bell curve. Later on, we'll talk about other left skewed, right skewed, and different types of distributions. But for now, just think about the normal bell curve. And I think you also have when you have students, I think you also you've worked with students before. When you look at the grade distributions, like just anytime you have any type of some type of statistical process, you will tend to have this type of normal distribution, and the expected value just is telling you roughly where the center of that distribution is.
Yeah.
So that's the underlying concept, and we won't go into. I mean, we could go deeper if you want, but I think for now, for what you need to do, this is a really So just make sure you understand this first equation, or this concept of expected value. So from here, we'll move on to the variance and standard deviation of a discrete random variable. So discrete is just meaning that we actually have very discrete numbers of home mortgages. It's either 1, 2, or 3. If it's continuous, it'd be like my weight or your weight, like, ranging from 82 kilos to 87 kilos, like, or 87.1 kilos, like that's a continuous distribution. So don't worry about like these fancy words, discrete and continuous. They just sort of describe the type of quantities that we're looking at. So we're looking at, so the first thing that we look at when we want to describe sort of the behavior or the sort of the characteristics of this distribution is the expected value. The next is the standard deviation, which is sort of the spread. So I don't know if we have an example here, but yeah, maybe later on I'll show you a different example. But I'm sure you've seen like there's skinny normal distributions and fat ones. Have you seen those? Like skinny would be like a lot of them are centered around 3, and then the fat one would be like a lot of 2s, 3s, and 4s and 5s. So that is the thickness of that and sort of how wide that that bell curve is encapsulated by the standard deviation and the variance. And so this is what we call it's just a summary measure. And the way we do that is we again sort of take this similar notation of the sigma notation, but here instead of multiplying by the probability outcome, you're doing it minus your expected value, which is mu, which is sort of what we described up here. When we collapsed it, this mu. So the mu is just expected value. And at each point I, and so this is maybe confusing if you've not encountered this notation, but basically your expected value mu is for each value that you have, you're going to take that difference and you're going to square it and multiply it by the probability, and you're going to sum that. And it sounds more complicated than it really is. But basically, if you put this in Excel, like it'll actually just compute this for you. And I don't think it's super valuable for you to have to work throughout the mechanics of this one, because once you've worked out the mechanics of the expected value, I think this one should also come pretty naturally. But I don't know if, you know, does this expression, the variance, does that sort of have some, does it sort of make sense to you, or not quite
Yeah.
yet?
Yeah.
Okay.
Is there an example of this when down a little bit further? Or?
Yes. So we actually will put this into a financial context. And then before I do that, I'm just going to tell you the standard deviation is just the square root of your variance.
Square root.
Yep. So that's pretty straightforward. And then these are also functions in Excel as well. And then did you have a chance to go through the linear regression module yet, Adam? I think you did, right?
Yeah.
Okay, good. Cool.
I finished that on Monday.
Great, perfect. So yeah, so anyways, if you want, you can actually go through this specific exercise where you can actually go through the same table that we saw before.
Yeah.
And so here we're just going through the exercise of, here's the 0 minus 2.8, and you'll notice 2.8. You see this 2.8 is through all of this, this equation. That's just your mu. And then each one, you're gonna step through. So the subscript I, you're just stepping through the values that x can take with that, what we call the probability mass function, which we so basically you're stepping through this value, this value, this value, this value, one by one throughout the distribution.
Yeah.
So that is, I know that that's sometimes a little hard to take on the first time. If you've seen, this is the first time you've seen it, it sounds a little complicated and this looks complicated, but really it's just a mechanical procedure to get out this number.
And if I understand this mortgage example, which seems like it's flowed onto the variance and the standard deviation, if I understand this exercise, will that set me up for the assessment?
Oh, absolutely, absolutely. I mean, it's a first step, but it will definitely get you, the assessment will. So this is what I'll have to say about the assessment. And Adam, I think this is what we're going through right now is like the definition. Like these are sort of like the basic building blocks. And so we will actually have more. I mean, there will be some that are just really simple definitions that you can choose A, B, or C. Is this a definition of the expected value? Is this the definition of variance and so forth? So there will be very simple ones. Where I think, you might need to think about is we do have some applications. For example, we move here from the mechanical application of this formula for variance, and we now talk about this in the context of finance, and we start talking about covariance. And what you're going to have to do is we will give you like some type of business problem. We'll tell you, hey, you are the investment manager, and you have to map out, like, we're now encountering inflation, or what's a probability. Our economists are mapping out, like, this is a probability of an expanding economy, a stable economy, and a recession economy. And then so you'll see here on the left hand side here, what the economists, and you don't have to worry about why they came up with these probabilities. You're just going to accept that, okay, these are the current estimates. And then based on that, this is how the Dow Jones Fund is expected to perform. This is the hedge against the weak economy fund, which is how it's going to perform in these different scenarios. When you sort of talk, so when we talk about decision making, really what we're doing is just we're mapping out different scenarios, and then the probability of each of those happening. And so you'll see very clearly the first thing to do this is you're going to have to know what the expected value for X, in this case it's the Dow Jones Fund, and what the expected value of the hedge fund, which is the mu of Y. So
and that expected value would be that very first step that you showed me.
That's correct.
Yeah.
So this is the first step. And then you also have to understand how to make this decision and how you're going to allocate your investment portfolio decision. You will also need to calculate the variance. And then you'll also of both the Dow Jones fund and the hedge against the weak economy fund or the hedge fund. And then you'll have to I wouldn't worry about the mechanical computation once you've done it once or twice, because it'll be pretty, I think it should be pretty self-explanatory, but let me know if you're struggling with that application. But I would just, I would just plug this into Excel and make sure you know how the Excel function works, so that then you don't need to worry about making some silly mistake on the assessment. But the point of bringing this up is the assessment, we're gonna have you probably work out a business problem, and it'll be like something very similar to this. I can tell you right now, your assessment is gonna be based off a real business problem. And then you're gonna have to incorporate, you're gonna have to think about okay, should I use, most likely you do, but you'll have to think okay, do I use expected value? Do I use the variance? How do I figure out, how to make this decision? And you're gonna have to use all of these different little elements to make that decision, and to justify, and you'll have to justify it too. So think about how you, think about how you would verbalize sort of the use of your expected, the expected value of these two different funds, the variance between them, and then the covariance. So that's sort of what we're going to be assessing on the test, if that makes any sense.
So with these equations in mind, if we make an error with our mathematics, we can still get marks from what we write, or
yes,
the
exactly
that we come up with. Okay.
Yes, exactly. So we're not too worried about, we're not going to assess you on the mechanics. Did you execute the mechanics? Because you can do that in Excel. We're thinking about the logic of how you walk through it and how you came to your conclusion.
So understanding the expected value, the covariance, the variance, understanding those concepts too.
Okay, cool.
Yeah. Okay.
That's massive. So if you can get that, then I think you should be. So once you understand that, then I think everything else should start to come. And so I'm glad that the notation is not as formidable as you might have thought. So I think the other thing just to note here, which I think Ankur pointed out here, just so you know, this should be an equal sign, not plus.
A plus sign.
So when you do have a variance of the sum of the two variables, so this should be an equal.
All right. Okay. The variance of the sum of two.
Yeah. And
then
so
need to know that 4.6.
Yeah, you're going to need to know. So it's an open book test. So you don't need to know it. You don't spend time memorizing it. But spend time understanding what it means, so that when we give you a word problem or business problem, you'll sort of know okay, this seems like this is what I would be using to solve this problem. And then here we've worked out an example for you, if you want to do, and it, I think now that you've sort of gone through some of the mechanics of it, now it becomes a lot easier. And one recommendation for you, Adam, is if this is the first time you've encountered this, either do it on paper or do it on Excel, so that you've labeled what the expected value for X is, what the expected value of Y is, what the variance, what the covariance is, and then so that then you can sort of just roughly, you'll have a structure for how you think about these word problems. And so then you don't need to it doesn't take that much time, but just the first time you do it, it can seem intimidating. So if you do, once you do it, then it should be a lot easier. So I think I would just say then you should also really think about portfolio expected return and portfolio risk. And so we have an example here, and this hopefully looks less daunting because we don't have the sigma notation. But I would strongly recommend you work through this example as well. But this is, again, just multiplication and subtraction and addition, and then 1 square root But this portfolio risk equation will probably have, some type of word problem that says, hey, you've got, you're an investment manager and you need to figure out, what the risk profile is and what your expected return should be. We won't have any, have you taken corporate finance yet?
Yeah.
Okay, did you do the Sharpe ratio and the expected, the boundary of risk and return? You
Yeah,
guys remember?
yeah.
Yeah. So this is going to be a simplified version of that. So as long as you have that piece, then I think you should be good.
Okay. All right, cool. So I'll just go back and go through those concepts and so unit 4.
Yeah.
Okay, and there's still
here,
scope for, yeah, sorry.
I was going to say here is that notation again. Here's the expected value of x minus mu x and y minus mu x. So this pops up again and again and again. So just make sure you understand the notation for expected value.
Yeah.
And then, sorry,
Okay.
I interrupted you. What were you about to say?
No, it's just just saying, obviously there's it's not just based on the mathematics, and can still obviously get marks for if I get a bit of that wrong, but I kind of still
Explain it.
Yeah. Okay. Yeah.
Absolutely.
All right.
Absolutely. So yeah, I wouldn't worry too much about the mechanics because there's not going to be, we're not going to be testing on your mechanics. We're going to be testing about your ability to integrate these different concepts together. Usually, typically in a business or finance application.
Yeah, well, I know someone that took, I know that this subject has kind of changed names and had a fresh bit of paint, if that.
Yes.
That last year they didn't have a exam, so I thought, okay, this is great. So I wouldn't be under pressure with any mathematics, but it seems like it has changed to a test. Yeah.
Oh, if this was taught, was it taught by Yaron last time? Do you know, or?
I'm not sure, but
okay.
He did it last year and there was no exam.
Oh, really? Because
there was no time test, no.
Oh, because I feel like, from what I understand, if it was taught by Yaron or Kimji, it was there's always been 2 assessments that are quantitative. One is the quantitative methods and linear regressions, and then the second one would be units 1 through 5. But then after that,
I think what he did was had that other assessment, but it wasn't like a timed test. It was still asked them to create an answer to a problem via a PowerPoint. Wasn't an actual test. So it has changed over time, but it is great that you've increased the participation mark.
Right. Yeah. We want to make sure that we're buffering against students that might feel that they're not going to do well in the test. But I should also that the test is going to be the one for testing units 1 through 5. It is 1.5 hours, but we've designed the test to be taken within 50 minutes, 45 minutes to 50 minutes. So you should have like 45 minutes, 40 minutes extra.
Great.
So that you won't be under time pressure.
Oh, good.
Yeah.
Good. Okay. Yeah. Excellent. Thank you.
Yeah, absolutely.
For your help.
Yeah, absolutely. Yeah. So, so let me know if you have any other questions. Actually, having gone through this just right now, like I should actually let you know, I just met with a former student that took this just last term. She was an art history major, and she was working at Volkswagen, and she's looking to get out and work at an AI company, but she's afraid of the tests and afraid of the math. And now she just told me she got a job at an AI company.
Oh, wow.
Yeah. So just to let you know, like, people, it sounds daunting. Some of these, maybe some of these equations look daunting, but I think if you work through the examples, and she felt like, as long as she worked through examples, like she felt like she gain enough mastery. Obviously, you're not going to be a mathematician, you're not going to develop code, but at least you can talk the talk and understand, like, if somebody asks you something, you sort of know how to think about it.
Yeah, absolutely. Thank you.
Yeah,
Thank you
thank
for
you.
your time.
Yep, absolutely.
Excellent.
Thanks, Adam.
mate. Thank you.
And Jeffrey, do you have any other
Bye.
questions or?
No, I just thought I'd stick around because I was probably gonna just watch the recording just in case later.
Yeah,
So,
yeah.
Thanks.
Now you don't have to
Thank
watch the
you.
recording.
Yeah.
All right. Thanks, guys.
Thanks, guys.
Thank
Bye.
you. Bye.
Have a good weekend.